So in our last class, we did up to number 9, right? And number 9 and 10, these are pretty similar. So let's finish the remaining, then we'll be back and just do a review one more time, okay? So up to number 10, do you have any question? Okay. Okay, now let's start. Okay, so we have number 11, number 13. Okay, we have 3 more. Okay. So in number 11, we are given a polynomial inequality and we need to write down the solution in the interval notation. Okay, we have to solve this inequality and write the solution in interval notation. Okay. So this is the polynomial inequality, and what is the very first step of solving polynomial inequality? We make one side of this inequality equals to 0. Okay. Now, you can just pick your side, left side or right side, it doesn't matter. So it's going to be easy for us to make 0 on the right side, right? And how do we make 0 on the right side? So we have 6 on the right side. And how do we get rid of this 6? We subtract 6 on both sides. So let's go ahead and subtract 6 on both sides. This is the very first step, okay? You are making one side of your inequality equals to 0. Again, it's the same, and you do this step for rational inequality as well. So we have, let me write down here, 2x squared minus 7x, okay, positive 2 minus 6, that is minus 4. We have less than, and positive 6 minus 6, that is 0. So this is the very first step. So you are making 0 in one side. Next step, we factorize the other side. Like once you have the 0 on the right side, now you need to factorize completely the left side. So we have trinomial, okay, quadratic trinomial, and we have to factorize this trinomial. And what method do we use to factorize here? AC method. And how we know that? So you see the coefficient of a square term. If the coefficient of a square term is other than 1, then we use the AC method. So this is our A, right? This is our C. So let's multiply A and C. We get A is 2 times 4, we get 8. Okay. Now we write down every pair of factor of 8. 1, 8, right? 2, 4, 8, 1. So these are the pair of factor of 8. Okay. Now out of these 3 pair of factor, we choose one pair of factor. Okay. We choose one pair of factor to rewrite our middle term, negative 7x. Now which pair of factor do we choose to rewrite negative 7x? 8 and 1, right? So you can add or you can subtract these pair of factors together to rewrite. So, oh, we're 1, 8, 8, 1 is the same pair of factors. So I think I can just erase this factor. It's the same pair of factor. So let's choose this pair of factor to rewrite negative 7x. Now, how do we rewrite negative 7x using 1 and 8? Minus 8x plus 1x, right? Or x. Okay. So here we have 2x squared. Now negative 7x is negative 8x plus 1x minus 4 less than 0. See, we use 8 and 1 pair of factor to rewrite our middle term. Okay. So we have 4 terms here. So let's make a group. First 2 term is a one group and last 2 term is other group. Now in the first group, what is the common factor? Do we have any common factor? 2x is the common factor. So let's factor out 2x. If we factor out 2x from 2x squared, we have, so you divide this 2x squared by the common factor. 2x squared divided by x, 2x is x. Okay, then negative 8x divided by 2x is negative 4. Okay, plus in the last 2 term we can factor out 1. So we have a 1 as a common factor. If you factor out 1 from 1x, we have x. If you factor out if you factor out 1 from -4, we have -4 and less than 0. So this is common. So let's factor out x minus 4. Okay, so our x minus 4 is a common factor, and the remaining is 2x plus 1 less than 0. So we have our left side in a complete factor form. So we have this factor, x minus 4 factor, and we have 2x plus 1 factor. Any question up to here? Now, once you have the complete factor, we write down the zeros of each factor. Now, let's write down the zeros. Okay. Now, we have two factors. So, we're going to get 2 zeros. This is a quadratic inequality. So, you're going to get the 2 zeros. If you have a cubic inequality, then you're going to get the 3 zeros. Okay. Now, we take now for what x value this first factor is 0. Can you tell me a x value such that x minus 4 is equals to 0? For what x value x minus 4 is 0? Positive 4, right? Okay, 4 is the 0. Now for what x value this factor is 0? So you have a 2x plus 1, and we need to find x such that 2x plus 1 is equals to 0. You can solve this, okay? Like, so we want our 2x plus 1 equals to be a 0, right? So let's solve this. You subtract 1 on both sides. This cancel. You have 2x equals to -1 divided by 2. So x equals to -1/2. So if you choose your x to be 1/2, then this expression is 0. See, 2 times -1/2 is -1 plus 1 is 0. Okay? So -1/2 is our second 0. Okay, so you list every zeros. Now we use these zeros to form an interval. Okay, so let's draw a number line. So now we're gonna use these zeros to form an interval. So let's use a number line here. So we have a number line, positive infinity, we have negative infinity. Okay, so do we write -1/2 first or 4? So in the number line, so -1/2 is on the left, right, and positive 4 is on the right. Okay, make sure you write in the correct order. Okay, after this, so you see we have a 3 interval. So we have this interval. Okay, so we have this interval and the last interval. So we have 3 interval, and we need to check whether these intervals are the solution for the inequality or not. And how do we do that is that we pick any number from each interval. Now from the first interval, what number do you want to pick here? -1. Let's go with this. Okay, from the second interval, let's do 0, right? That's gonna make us easy. And from the last interval, let's pick 5. And it doesn't matter what number you pick. Okay, now we need to check all these number. We need to check whether -1 is a solution or not. We also need to check whether -1/2 is the solution or not. 0, 4, and 5. Now let's check whether these are the solution for our inequality or not. Now let me write my inequality. So our inequality is, so I can use this one inequality. Okay, it's the same thing. So x minus 4. So our inequality is, x minus 4 times 2x plus 1 less than 0. Or you can use this one. Okay, it's the same thing. You can use this inequality. Okay, so this is in a factor form. That's the only difference. But these two are the same inequality. Now, for this inequality, is -1 a solution or not? So you substitute -1 for every x in your inequality. Now let's see. So -1 times -4, -5. 2 times -1, that is -2 plus 1, -1. Now we have -5 times -1, +5 less than 0. Is it true or false? False. It means this interval is not a solution. Okay. Now let's check for -1/2. So -1/2 minus 4. -1/2 is -0.5. So we have -4.5 times negative 1 half time 2 is negative 1 plus 1 is 0 is less than 0. So we have 0 less than 0. True or false? False, right? So it means negative 1 half is not a solution. It means, do we use an open circle or a closed circle at negative 1 half? So we use an open circle. Okay, it's not a solution. So this is open circle. Now let's check the second interval. So we use 0 here. So let's check 0 is a solution or not. So 0 minus 4 minus 4. 2 times 0, 0 plus 1 is 1. So negative 4 is less than 0. It's true, right? So this second interval is the solution. Now let's check for 4. 4 minus 4, 0 times, we have like, it is 4 plus 2, 8 plus 1, 9. So 0 less than 0. It's false, right? So 4 is not solution. So we're going to use an open circle here. Okay. Now let's check 5. So you substitute 5. 5 minus 4, 1. 2 plus 5, sorry, 2 times 5, 10 plus 1, 11, less than 0. It's false, right? So this is not a solution. So our solution is from negative 1 half to positive 4. So from negative 1 half to positive 4. Now, do we use a parenthesis or a bracket? We have an open circle, parenthesis here. And this is the solution for this polynomial inequality. And if you have a two interval solution, you're going to use the union sign. Okay. Sometimes you might get a two interval as a solution and you use your union sign. Any question? Okay. So let's go to the next one. So number 12 is pretty similar. Okay. Like once we finish, then we'll just come back to number 12. Okay. We'll do in a group. Okay. Let me go to number 13 and here, okay, let me pick number 14, okay, and 13 and 14, these are similar, but let me do number 14. So here we have the rational inequality and we have to solve this inequality and write the solution in the interval notation. The very first step, we make 0 in one side. We already have 0, right? So we can skip this one. Next step, we factorize. Now this is the rational inequality. We have the numerator, we have the denominator. So we have to factorize numerator as well as denominator. Now let's factorize our numerator and denominator. In the numerator, do we have any common factor? 2 is the common factor, right? So let's factor out 2. So if you factor out 2, from 2x we have x. And if you factor out 2 from positive 4, we have positive 2. This is the numerator divided by. Now in the denominator, what method do we use to factorize? AC or FOIL. This is the quadratic. So we have the two options, AC or FOIL. The coefficient of square term is 1. So we're going to use the FOIL method. Now what should be the first term? So the product is x square, x and x. Now let's find the two number, okay, whose product is negative 6 and sum is the coefficient of x, which is positive 1. Give me a two number whose product is negative 6 and sum is positive 1. Negative 2 and positive 3. So negative 2 and positive 3. Okay, greater than 0. So you factorize numerator as well as denominator. Now the next here, we need to write down, okay, we need to write down the number that make numerator 0 and that make denominator 0. Now let's go to the numerator. So for what x value this factor is 0? So negative 2, right? So the zeros for this function, 0 is negative 2. Okay, so you find the x that makes numerator 0, that is the 0. The next, we also need to write down the x that make denominator equals to 0. So we have this factor. For what x value this factor is 0? 2, right? So but 2 is not a 0 for this function, okay? Okay, just let me write an x value for which denominator is 0. Okay, and this is, so when we had a polynomial function, see, we didn't had this step. Like if we go back here, so in the polynomial function we just found the zeros, right? The polynomial function, they don't have the denominator, we only find the zeros. But in the rational function or in the rational inequality, we have the denominator and we have to include the number that make denominator equals to 0. Okay, so this factor is 0 when x is equals to 2, right? So when you choose x equals to 2, your denominator is 0. Similarly, when you choose x equals to, what do we need to choose so that this factor is 0? Negative 3, right? So when you choose x equals to negative 3, then your denominator is equals to 0. So whenever you have the rational inequality, you need to include the number that make numerator 0, which we call the 0. Okay, and you also need to include the x values that make your denominator equals to 0. Okay, and the easiest way is you factorize numerator, you factorize denominator, and you look for the x that make each factor equals to 0. Okay, now we use these three number to divide our number line into an interval. Okay, so we have a number line here from negative infinity to positive infinity. So we have negative 2 on the left, negative 2. We have positive, okay, oh, we have a negative 3. So let's start from negative 3, okay. Negative 3 is on the left. So let's say this is negative 2 and we have positive 2. So you divide your number line into interval with the help of these x values. Okay. Now, as we did earlier, we pick a number from each interval. Okay. So on the first interval, let's pick negative 4. Okay. From the second interval, we need to go the decimal, right? So negative 2.5. Let's pick negative 2.5. From the third interval, let's do 0. And from the last interval, let's do 3. Okay. Now we need to test all these numbers. Okay. So negative 4, negative 3, negative 2.5, negative 2, 0, 2, 3. We need to check all these numbers are the solution for our inequality or not. So let me write down the inequality. Our inequality is, I'm going to use a factor form. Okay, so it's going to be easy for us. So we have 2 times x plus 2 divided by x minus 2 times x plus 3 greater than 0. Okay, and you can use this one. Okay, it doesn't matter, you can use this also. These two are the same, only their form is different. Okay, now let's check whether negative 4 is a solution for this inequality or not. Okay, so you substitute negative 4 for every x. So we have 2 times negative 4 plus 2 is, so negative 4 plus 2 is negative 2. Negative 2 times positive 2 is negative 4. So we have negative 4 in the numerator. So we have negative 4 divided by negative 4, negative 2, negative 6, negative 4 plus 1, that is negative 1. So this is negative 4 divided by positive 6. And it is greater than 0. Is it true or false? False, right? So this interval is not a solution. Okay, now let's try for negative 3. So you substitute negative 3 for every x. So negative 3 plus 2, that is 5. 5 times 2 is 10. So 10 in the numerator. Negative, oh, not 10, I'm sorry. So we are using negative 3, right? So negative 3 plus 2, that is negative 1. Negative 1 times 2 is negative 2 divided. So negative 3, negative 2, negative 5. Negative 3 plus 3, that is 0. So we have 0. So we have negative 2 over 0, which is undefined, right? Undefined means this is not a solution. So every time if you have the 0 in the denominator, this is undefined. So negative 3 is not a solution. If negative 3 is not a solution, do we use a closed circle or an open circle? Open circle. So we're going to have an open circle here. Okay. Now let's try for negative 2.5. Okay, negative 2.5 plus 2, that is negative 0.5. and negative 0.5 times 2 is negative 1 divided by negative 2.5 negative 2, that is negative 4.5, negative 2.5 plus 3, that is 0.5. So we have negative 1. So we get negative number in the denominator, right? And negative 1 divided by the negative, that is we get the positive number, and positive number is greater than 0. That's true, right? So our second interval is solution. We don't need the exact number. You just need is a positive or negative here. Okay. Now let's check for negative 2. So negative 2 plus 2, that is 0. Okay. So we have 0 in the numerator. Negative 2, negative 2, negative 4, negative 2 plus 3, positive 1. So we have 0 divided by negative 4, 0 greater than 0. That's false, right? So negative 2 is not a solution. It means we're going to use an open circle at negative 2. Now let's try for 0. So when you are testing for 0, you are testing all this interval, okay? Not the specific number. Okay, so is our 0 a solution for this interval or not? Let's try. So 0 plus 2, 2 times 2, that is 4. 0 minus 2, minus 2. 0 plus 3, 3 is greater than 0. That's false, right? So 4 divided by negative 6. So a negative number is greater than 0. That's false, right? So this is not a solution. Now let's check 2. So 2 plus 2, 4. 4 times 2, 8. Divided by 2 minus 2, 0. So we have 0, which is undefined. It means this is not a solution. Now let's try for 3. 3 plus 2, 5. 5 times 2, 10. 3 minus 2, that is 1. 3 plus 3, 6, greater than 0. 10 divided by 6, that is greater than 0, right? So this is a solution. So our interval, so this interval is the solution, and this interval is the solution. Now let's write this interval. So from negative 3 to negative 2, from negative 3 to negative 2, you have an open circle at both, so you're going to have a parenthesis. And the last interval from 2 to positive infinity, not 3, okay? Not 3. We just pick one number from this interval, so you go all the way to the right, positive infinity. At 2, open circle, infinity always open parenthesis, and you're going to use a union, and this is the solution for this inequality. Good. Okay, now let's go to the next one. So we have a 15 and 16. These two are similar. So let me pick number 16. Bless you. So here we have x equals to 3 plus I is a 0 for this polynomial. We need to find all three zeros of this function and write the polynomial as a product of linear factor. Okay, we know that x equals to 3 plus I is a 0. This is what is given to us. And what kind of 0 is this? Is this a real 0 or a complex 0? 3 is a complex number and it's a complex 0, right? Now, I forgot to mention one thing when we had a lecture on this topic. So if you have a complex 0, the conjugate of this number, okay, so we have this number, complex number, and this is a 0. The conjugate of this number will also be a 0 for the same function. Now, did we do a conjugate? Now, here is the thing. So, conjugate means we flip the sign of I terms. Okay, if you flip the sign of I terms, then you get the conjugate. So, we have a 3 plus I. So, I is positive, and you just change the positive to negative. So, we have 3 minus I, and that is the conjugate, okay? So, 3 minus I, this is the conjugate. And this conjugate is also a solution for the same polynomial p of x. Okay, if you have a complex if you have a complex solution, then its conjugate will also be a solution. Okay. Now if we go to number 15, so we have this 1 minus 2i as a zero, complex zero, right? So x equals to 1 minus 2i is a complex zero, and what will be its conjugate? What is the conjugate of 1 minus 2i? You flip the sign of I term. Okay, the I term is negative, so you flip it, so 1 plus 2i, and this is also a complex zero. Okay, this is what I forgot to mention in the lecture class. So if you have a complex zero, its conjugate is also a zero for the same function. Okay, now x minus 3i is also a zero, right? Okay, now our target is finding the 3 0. So we already have 2 0. So we have 3 plus I, 3 minus I. So we have the 2 0, and we need to find one more 0. Now, so what does it mean? So if 3 plus I is a 0, what is the corresponding factor? How do we write the corresponding factor? So if we have any number is a real 0, let me take 4. Okay, for example, if 4 is a real 0, what is the corresponding factor? It's always x minus 4, right? And we use the same concept. So we have 3 plus I is a complex 0. So the corresponding factor is x minus this number, okay? So the factor here, so this is a 0, so corresponding factor is x minus, every time x minus 3 plus I. We have a more than one term, so we're going to use a parenthesis, 3 plus I. So this is one factor, okay? And if we simplify, this will be equals to x. You distribute negative, you have negative 3, negative I. Okay? Now, similarly, if 3 minus I is a 0, then the corresponding factor is, x minus and this 0, which is 3 minus I. 3 minus I. You have more than one term, so make sure you have the parenthesis. Now you distribute negative, we get x, negative times 3, negative 3, negative times negative I, we get positive I. Any question up to here? So we have the two factors for this polynomial, okay? Now we need to find one more 0. Finding one more 0 means we need to find one more factor, okay? Now let's find one more factor, and for that, so we already have two factor, so let's multiply these two factor, and that will be our divisor here, okay? So we have these two factor, so our two factor is x minus 3 minus I and x minus 3 plus I, okay? These are the two factors for this polynomial function, okay? Now we are trying to find the divisor. So let's get rid of I here, okay? So we don't want I here, and how can we? So if we distribute, how can we get rid of this I here? Okay, now we have this two factor. Now let me call x minus 3 is a one term, okay, and I is a different term, okay. Let me call x minus 3 is a, okay, x minus 3 is a, and I is b, okay, I is b. So what do we have here? A minus b time a plus b. And what is this equals to? So if we have a minus b time a plus b, when we multiply these two binomial, what do we get? We get a square minus b square, okay? Or you can use the FOIL here. Now let's use this concept, it will be easy for us, okay? So our a square, our a is x minus 3, so our a square is x minus 3 square minus b square, our b is I, and I square. Or you can use the FOIL, okay? I mean, you can just distribute x for x minus 3 plus I. You can distribute negative 3 for each term. Okay, you can use a distribution, or you can go with this one. Now let's simplify this. Okay, x minus 3 is same as x minus 3 times x minus 3. Do you agree? Right? Minus, what is I square? I square is equals to negative 1, right? I square is always equals to negative 1. Okay, now let's use FOIL here. So x times x, that is x square. Okay, then you multiply the outside term, you multiply inside term, and you multiply last term. So first term x times x, x square. Outside term x minus 3, x times minus 3, that is minus 3x. Inside terms minus 3 and positive x, that is minus 3x. Last terms minus 3 minus 3, that is positive 9. Minus times minus 1, that is positive 1. So this is x square minus 6x plus 10. So when you multiply the two factor for this polynomial, this is what we get. And this is, now we take this as our divisor. Okay, now we call this is our divisor. Okay, and divide this polynomial, okay, and get the quotient, and quotient will be our other factor. Now in this case, can we use a synthetic division? Our divisor is x square minus 6x plus 10. Okay, we can't use synthetic division. Okay, and the reason is that excuse me, every time if you want to use a synthetic division, our divisor must be of x minus some number form, right? But here we have a square. Okay, so we can't use the synthetic division, so we're gonna use the long division. Okay, so we are dividing our polynomial. This is our polynomial, so we are dividing this polynomial by this divisor. So let me write our polynomial is x cubed minus 7x square plus 16x minus 10. And we divide this polynomial by our divisor x square minus 6x plus 10. We use a long division, and the method is we divide the leading term of the dividend. So this is the dividend. So the leading term of the dividend by the leading term of the divisor. Okay, so x cubed divided by x square is x. This is the quotient, first term of quotient. Okay, next step, we multiply this first term of quotient and every term of the divisor, and write in the second row. So x times x square, x cubed, x times negative 6x square, x times positive 10, that is positive 10x. Then what is the next step? We flip the sign, right? We change the sign. X cube is positive, so we make it negative. Negative 6x squared, this is negative, so we make it positive. 10x is positive, we make it negative. So x cube minus x cube, this is 0. Negative 7x squared, positive 6x squared, that is negative x squared. 16x minus 10x, that is positive 6x, and we drop this last term, negative 10. We repeat the process. So you divide the first term, negative x squared, by positive x squared. And what do we get? Negative x squared divided by x squared, we get negative 1. Now we multiply this negative 1 and every term of this divisor. Okay, so let me rewrite this. So we had x squared minus 6x plus 10. So you are dividing, okay, every term. So we have negative 1 as our second term for the quotient. So you multiply negative 1 and every term here. So negative 1 times x squared, negative x squared, negative 1 times negative 6x, that is positive 6x, negative 1 times positive 10, negative 10. Now we change sign. Negative x square is negative, we make it positive. 6x is positive, we make it negative. 10 is negative, we make it positive. Okay, and make sure to use the new sign. Okay, negative x square, positive x square, 0. Positive 6x, negative 6x, 0. Negative 10, positive 10, 0. So we have 0. This 0 is our remainder r of x, and this is our other factor, which is the q of x. Okay, now our function, we can always write our polynomial function as a divisor time q of x quotient. So what is the divisor? Divisor is x square minus 6x plus 10 time q of x is x minus 1. Okay. Now can I replace this by our 2 factor here? It's the same thing, right? So this expression and the product of these 2 factors, these are the same thing, right? We just multiplied the 2 factor. So I can replace x square minus 6x plus 10 by the factors x minus 3 minus I times x minus 3 plus I x minus 1. So this is our polynomial function in a factor form. Now from here, what is the other 0? We already know the 2 0. Can you tell me one more 0 for this function? 1, right? And this is a new factor. That's what we calculated by long division. Okay, and we want a number that make this factor 0. So 1 is the other 0. Okay, third 0 is 1. This is a lot, right? Now let's go the easier way. Okay, I mean, you are not required to do this method, so we have the easier option. Okay, now any question before we go to the easier option here? But like whatever we did here is not the new one. Okay, it's everything we did a lot here. Now let's do this example 15. Okay, so we need to find the 3 zeros. We already have 2 zeros, so we have this one and this one, right? And we need to write our p of x as a product of the factors. Okay, now let's find the zeros for this function. One more 0 for this function. Okay, this is our polynomial function. P of x equals to x cubed minus 4x squared plus 9x minus 10. Now how do we find the real 0? To find the real 0, what make us easier to find the real 0? We introduce 1 0, rational 0. So let's use the concept of rational 0. Okay, so our rational 0 is p over q, right? P is the factors of constant, which is 10, and q is the factor of coefficient of leading term, which is 1. So factor of 10, what are the factors of 10? 1, negative 1, 2, positive 2, 5, negative 5, 10, negative 10. Divided by factors of 1 is positive 1, negative 1. And if you divide all these number by positive 1 and negative 1, 1 by 1, we end up getting the numerator, right? So our p over q is 1, negative 1, 2, negative 2, 5, negative 5, 10, negative 10. So we have this. Now you have these number options. Now you pick one number, you substitute for every x in this function. Okay, you substitute for every x in this function, and you look for the number that make output equals to 0. And that number is a real 0. Okay, now let's start with positive 1. So if we choose positive 1 for this function, is our function 0 or not? Let's find out. So let's do it positive 1. So 1 cube minus, so we have 1 minus 4, that's minus 3 plus 9 plus 6 minus 10 minus 4. Okay, so 1 is not a real 0. Now let's go with a negative 1. Okay, negative 1 cube, we get negative 1, negative 4, that is negative 5, negative 9.
2 is the real 0.
2 is the real 0. Okay, so negative 1 is not a real 0, so 2. Okay, so 2 cube, 8 minus 2 is square, 4. 8 minus 16, minus 8 plus 18. That's plus 10 minus 10, 0. Yes, so 2 is the real 0. Okay, so our other real 0 is 2. You don't need to use the long division because at least one number will be a real 0. Okay, it might take, you do have the access of calculator, so just you need to make sure you check every, okay, and always you start from 1, negative 1, okay, and then you go for the bigger number. So 2 is the real 0. See, once we know, we could have, we had to wait up to this point to find the other real 0. So you are not required to do everything here. Now, so we found the all zeros, okay, so these 3 are the zeros. Now let's write the p of x in a factor form. So our p of x is, so once we know the 0, we can write the corresponding factor. Okay, so if 2 is the 0, what is the corresponding factor? X minus 2, right? We know 2 is the 0, so x minus 2 is the corresponding factor. So if 1 minus 2i is a complete 0, what is the corresponding factor? X minus this number, 1 minus 2i. Make sure you have the parentheses, okay, because you have more than one term. And the factor corresponding to this 0 is x minus this number, 1 plus 2i. And you can just leave here, or if you want, you can simplify, distribute a negative. So we have x minus 1 plus 2i, x minus 1 minus 2i. Okay, so if you have this much, then yeah, you should be good. And okay, do I want you to get rid of I or not? Okay, will it be easy for you to get rid of I here? The concept gonna be same, okay? So if you wanna get, now since it's a polynomial and we should not have a I in a polynomial, we need to get rid of I. So what do you do? So you call this is your A, okay, and this is also your A, and this is B, and this is B, and we use the one that we had earlier. So we have x minus 2 times a square, a is x minus 1 square, minus b square, b is 2i square. So this is x minus 2, so x minus 1 square. Now what is this? 2 square is 4, I square is I square. So this is x minus 2, x minus 1 square, I square is minus 1, minus 1 times minus 4, that is positive 4, so this is minus 1. So we have positive 4. Okay, at least I want up to here as a final answer, okay? And if you can still distribute here, you can still simplify here. X minus 1 square is same as x minus 1 times x minus 1. Use the FOIL, collect the like terms, okay?
So on number 16,
Yes.
when we wrote it back into the p equals x,
Right.
we did put I back in. So did we need to use the...
Oh, okay. Now, if you use this method, yeah, you don't need this one. Thank you for that. So if you want to use this method, then yeah, but we had to do it here. See, yeah, we had to do somewhere. Yeah, we did here. So yeah, you can pick any method. Okay. Okay. Do you have any question? And make sure you practice now here. Make sure you practice similar function. Okay, so what you can do is that you can just take the different function from your book, okay, like from your homework, and you can just practice. So do not expect exactly same function, but you will have this type of question. Like, so we have 16 means you will have like a 8 question. Okay, the first question is similar to 1 and 2. Okay, then you have a second question similar to 3 and 4. Okay, so you have like a one type of question from 1 and 2. Similarly, one type of question from 5 and 6. So you're gonna have a 8 question. Okay, but do not expect exactly same function. Your function will be different. Okay, so let's do this much. If you have any question, I'll be here for 4 more minutes.